Gentlemen, and welcome back. Today we're going to be going over some Envision math stuff, mainly compositions of functions. Actually, that shouldn't be composition of functions. That should be composition of transformations. Oops. All right, well, let's fix that right off the bat. Should I re-record? Of course not. Can't do that live, so why would I do that now? Okay, we're looking at compositions of transformations. So previously we learned of a few different types of transformations, and we're doing like baby level transformations, so these aren't too difficult to do. The first one that we did was something called a translation. Now a translation takes a figure and moves it. So moves the figure. And it moves it either left, right, or it moves it up, down. And we figured out how we can do that. So let's say for a moment that I had a triangle, and let's name this one Hal, H-A-L. And let's say that we pick up Hal and we move him somewhere else, right? So he's in this giant spaceship back in 2001, and we move Hal over to the corner because we don't want him to be up in the right anymore. And then Hal says, I don't like it in here, it's too dark. So we move him up and to the right so that he's right underneath the translation thing. And then Hal says, no, I don't like it here either. So we lock him into a corner and we talk to him for a little while and he says something about his mind going, Dave, and then eventually he goes poof. But in all these different translations, Hal didn't change his shape or form or angles or anything. He just stayed as Hal. So that's what a translation does, is it moves it around in that fashion. And then we had another one. And this one was one where we spent a lot of time in thinking about it on our own, by ourselves. In fact, we spent a lot of time in self-reflection on it. I can hear the moans now. Yes, we're talking about the next type, which was a reflection. And the way we figured out how to do a reflection is that each point was equidistant from the line of reflection. So let's say for a moment that I have good old Hal on a set of axes. So let's draw the set of axes. Oh, that was horrible, Mr. Nail. Try again. Okay, try to stay on the line, Mr. Nail. Come on, you can do it. You can do it. Yay! Okay, I mostly stayed on the L. Right, if we had Hal, right? And Hal looked like this. And each one of his points would have a set of coordinates. So let's name Hal again, H-A-L. And for this one, we'd say H was at, let's see, that's 2, 1, 2, 3, 4, 5. So H is at 2, 5. A is at, let's see, 1, 2, 3, 4, 5, 1. And L is at 2, 1. Now let's say for a moment that we reflect Hal over the y-axis. So this guy right here, we reflected over the y-axis. When we did that, we created a new Hal where every point was equidistant from the edge of the line. So see how this is 2 points away on the right? Now it'd be 2 points away onto the left. If it was 2 points away on the right, now it's 2 points away on the left. And the last one was like, what, 5 points away? 1, 2, 3, 4, 5 points away. So now it's 5 points away, 2, 3, 4, 5, to its new place. And each one of these guys was, of course, labeled with a prime to represent the change. So we'd have H prime, which, if we remember, would be at 2, negative 5. No, wait, that's not right. Negative 2, 5. Let's get your positives and negatives correct, Mr. O'Neill. Come on, you can do this. Hashtag signs matter. Hello. A prime is suddenly at negative 5, 1. And L prime is now at negative 2, 1. So going over to the other side, we have H prime, L prime, sorry, and A prime. So that Hal now looks like this. Could say that Hal flipped out. No? Okay, well, I will reflect upon that pun and come up with a better one later. Could say some of these actually hold water. Because, water reflects and you can see your reflection in the water. Does that work? No? Tough audience. But Mr. Neal, you're not actually here. How do I actually hear you guys? Well, I don't. I'm just anticipating how you'd react. So we have the reflection, we have the translation, and then of course we have the next one, which brings us full circle because that would be a rotation. And with a rotation, this goes, it's a rotating about the origin. We don't have a method to do these at any location other than the origin just yet, but you learn more about them later on. And it's by 90 degrees, right? So like the first 90 degrees is 90 degrees, the second 90 degrees is 180 degrees, the third 90 degrees is 270 degrees, and the third 90 degrees would make it 360 degrees. But we don't care about that because it brings us back to where we started, full circle. So we really only care about those guys. And if we remember, the 90-degree change had the X and Y become inverted. And I believe the X value went negative, but I'm not sure. So that's the beautiful thing about notes. You can go back into your notes and determine if that was the case. And yes, it is. Nice. I remembered correctly. Yay. Go, Mr. O'Neill. Quit rolling your eyes at me. Thank you. All right, for the 180 degrees, we just took the X and the Y, and instead of being positive, we just made them negative. And then for the 270, for our X and Y, once again, we're going to invert our X and Y, only this time we're going to make the X negative. So what does that have to do with today's lesson? What does rotation and, oops, I didn't mean to cross that out. What does rotation and reflection and translation have to do with today's lesson? Well, for today's lesson, instead of just doing translations, instead of just doing reflections, instead of just doing rotations, we're going to have multiple transformations done to our beautiful shapes and try to figure out what happens to them. And yes, you can do this. You can have multiple transformations take place. I've seen many people go over multiple transformations. I've seen people go from being amazing students with a bright future ahead of them to crashing and burning because they decided to emphasize things that led to their own downfall instead of making wiser choices, like pay attention in class and doing their homework and going on to further their education outside of school, outside of high school. And I've seen some kids that had the absolute worst attitude you could possibly have turn their attitudes around and start really emphasizing the things that matter and turn their lives into something wonderful. A lot of kids usually ask me, Mr. O'Neill, who's your favorite student? Well, the answer is a kid who did exactly that. They took their very poor hand that life had handed to them and turned it into something wonderful through a lot of hard work. So, hard work time. Let's say for a moment that I have a trapezoid. And this trapezoid is going to be named something. I don't know what I'm going to name it yet. Hold on. Let me make my trapezoid first, okay? So here's my trapezoid. And it needs to be named, I want to name it Admiral Akbar, but unfortunately I can't, possibly because of copyright reasons, because there's a company out there that owns the right to this person nowadays. But he's famous for the line, "It's a trap." So I'm gonna call this no, not here. Ha! I found a way around it. I'm gonna call it a trap. Because dyslexia. Anyway, so I've got this trapezoid. Its name is TARP. And what I'm going to take is, I'm going to take this guy, and what I want you to do is I want you to rotate our TARP 180 degrees. Then after you've rotated it 180 degrees, I want you to translate it to the right 3 spaces and down 1 space. So it's on the board right now. And you're like, but Mr. O'Neill, I can't do this. It's too hard. And I say, yes, you can. Just break it down into simple steps. You know where all the points are for our TARP. If you need help, there's a dot, there's a dot, there's a dot, and there's a dot. So go ahead and try it. Go ahead and try. It's easy to count. It's so easy that some vampire on Sesame Street does it all the time. Yeah, somebody once asked me who my favorite vampire was, and I said the one from Sesame Street. And they told me, he doesn't count, and I assured them, he does. Yep, there's no escaping my bad jokes, is there? All right. So at this point, you should have been able to pause the video and try to do these transformations on your own. What I would do if I was looking at these transformations is I would do them one at a time, and I would do them to their coordinate points. So first I would write down all of their coordinate points, T, A, R, and P, because this is a trap. T is at the coordinate point 1, 2, comma, what is that, 3? 1, 2, 3? Yep. So T is at 2, comma, 3. A is at 1, 2, 3, comma, 3. R is at 1, 2, 3, 4, comma, 1. And P is at 1, 1. And then I would start with the different transformations. The first one is the rotation to 180 degrees. So when you rotate 180 degrees, I'm going to do this in a color so I can see it a little bit easier. When I rotate 180 degrees, that means I take my x, comma, y, and it converts into negative x, comma, negative y. Oh, that's easy enough to do. So now I'm going to have my first transformation, which is going to be t prime, a prime, r prime, and p prime. And the x and the y are going to be negatives. So now I'm looking at negative 2, comma, negative 3. For a, I'm looking at negative 3, negative 3. For r, I'm looking at negative 4, comma, negative 1. And for p, I'm looking at negative 1, negative 1. So that's the 180 degree transformation. And then I'm supposed to move it to the right 3 and then down 1. So to the right 3 means that I would take my x coordinate and I would add 3 to it. The down 1 means I would take my y coordinate and I would subtract 1 from it. So for t prime to become t double prime, because this is its second transformation, you use double prime for second, triple prime for third, quadruple prime for fourth, etc., etc., etc. So it says that I'm supposed to add 3 to the x. So negative 2 plus 3 for the x coordinate. And then we're supposed to subtract 1 from the y. So negative 3 minus 1. So that's really at the coordinate point, let's see, 1 comma negative 4. So I go to 1, negative 4, and that would be my t double prime. Now for the a, we do the same thing. I'm just going to go ahead and do it in my head here. Negative 3 plus 3 is 0, and then negative 3 minus 1 is negative 4. So I'm at 0, comma, negative 4. So 0, comma, 1, 2, 3, 4. And then the r double prime is going to be at negative 1, comma, let's see, negative 1 plus, oh, that would be negative 2. So then I go negative 1, negative 2. And for p double prime, let's see, negative 1 plus 3 would be positive 2. And negative 1 minus 1 would be negative 2. So I go to 2, comma, negative 2. 2, 2. And here is my, oops, if I could draw straight lines on here, new tarp. With t double prime, yeah, I should correct that. I know it's probably bothering people with OCD a lot that I didn't put this as an A. Anyway, t double prime, a double prime. Is that 0, negative 4? Which is this guy. R double prime and p double prime. So it's literally just doing it one step at a time, which means that you should have no problems with these. And believe it or not, if we wanted to undo our movements, there are ways that you can take your original figure and map it back to itself. For that, I think I'm going to let you experiment and try to figure it out yourself. Because a wise person once said, every piece of knowledge that I give to you is worth 5 that you can figure out for yourself. And for those who don't know, it's this old Chinese philosopher who wrote a book a long time ago that is still taught in every war college on the planet today. Just saying. Anyway, with that done, let's go ahead and jump to your favorite part. What? It's not your favorite part? What? You're starting to cry and try to walk around the room and do other things other than the things that you're supposed to be doing? Yeah. No, you're not allowed to do that. Go sit back down, pull out your pencil. You've got homework to do. And because this one's like super duper easy, and because we're going full circle and we've had time to reflect on things, and we're working on our translations from Mathanese into language that we can better understand, I think doing all of them would be a really, really good idea. It's only 13 problems, so that's not too much, and considering the length of this video is rather short, you should have plenty of time. Anyway, that's it for me. Go ahead and get started on the homework and work on it until the end of class. Smile and be happy. Have a great day. Bye-bye.